Trig functions, page 5. We're going to talk about the tangent function today. So tangent, remember, can be found by sine divided by cosine or by opposite over adjacent. Let's demonstrate this. Okay, so for example, sine divided by cosine is, or sine is opposite over hypotenuse, right? And cosine is adjacent over hypotenuse. So if I divide these two, do you see that the hypotenuses would cancel out? Let's just have a reminder of fraction math. So if you divide by a fraction, you multiply it by its inverse, or its reciprocal. So then the h's would cancel out and you would get opposite over adjacent, which is tangent, right? So tangent could be opposite over adjacent, or it could be sine over cosine. Okay, what happens to tangent theta when cosine theta equals 0? So if cosine theta becomes 0, which sometimes it is 0, then do you see how you would get tangent of theta equals infinity or undefined? So you could get tangent of theta equals positive infinity if sine is a positive value and cosine theta is 0, or you could get negative infinity if sine is a negative value and cosine theta is 0. Both of those happen. You could also write undefined. It's kind of convenient to know whether it's positive or negative infinity, because as you can see when we graph, it kind of tells you which way the function is going when it approaches the vertical asymptote it has. So tangent of theta, let's see, let's graph a few points for tangent of theta. So we already know that the tangent of 0 is 0, right? And then we also know that the tangent of pi over 4 is 1. And we also know that the tangent of pi over 2 is infinity. So it kind of looks like that. And then on the other side, it's symmetrical. It goes down like that at negative pi over 2. Okay? And then this pattern repeats over and over again. And if this the tangent is 0 at x equals 0, it's also going to be 0 at every 180 degrees. So at pi and 2 pi, etc. It's always going to be 0 again. So we can see that tangent repeats every pi units, right? So its period is pi. Different than sine and cosine, who has a period of 2 pi, right? What is the range of the function? You can see that it extends from negative infinity to infinity. Tangent has a vertical asymptote at x equals pi over 2. That's when the tangent is infinity. And also every, how many units to the left and right? It would be same thing as the period. Every pi units to the left and right, there's another vertical asymptote. So there's a vertical asymptote here at pi over 2, and then this would be pi over 2 plus pi, which would be 3/2 pi. Okay, here's the general function for tangent, and with the a, b, c, and d transformation parameters inserted. Like any other function, the amplitude is a. The principal axis, meaning like the height of the center point here, is going to be d. And the period of the function we said above is pi. Okay. Now, how could we find the relationship between the b value and pi? Remember that in sine and cosine, we have the relationship b equals 2 pi over p. It could also be written as p equals 2 pi over b. That's for sine and cosine. For tangent, since the period is pi instead of 2 pi, the relationship is written as b equals pi over p, or p equals pi over b. Okay, so it's a little bit different for tangent. All right, let's move down to number 1. Sketch the following functions for the domain 0 to 3 pi. Y equals tangent of x minus pi over 2. So first thing I'm going to do is I'm just going to draw the parent function of tangent. Just like I drew it above, it has asymptotes at pi over 2 and at 3/2 pi. And it has center points, like I wouldn't call it a vertex, but it's like the center of the function. The center of the function occurs at 0, 0, pi, 0, because at these points, tangent of 0, tangent of pi, the ratio is 0, right? And then there's going to be another point you can graph here, which is halfway between 2 pi and the asymptote. The height is 1, right? Because remember, the tangent of pi over 4 is 1, and then every single corresponding point has a height of 1. Okay, there we go. So this is the parent function, and now I'm going to graph this function, which is the parent function horizontally translated to the right by pi over 2. So that would mean it would look like this, right? I just moved all the red function curves pi over 2 to the left, or to the right, sorry, to the right because of bizarro world, right? Okay, now we're going to do something similar, except first I'm going to draw the parent function. Remember, the parent function has a point here that we can draw that is like pi over 4, comma 1. Okay. There we go. There's the parent function. And then this here is saying we're going to do a horizontal stretch or compression. B equals 3. If B equals 3, let's find out what the period would be. It would be pi over B. So pi over 3. So now what I did here is I zoomed in, and now I'm going to take all my red asymptotes, and I'm going to make them 3 times as frequent. So for example, this red asymptote here, I can't see it because I drew a blue asymptote on top of it. But pi over 2 is a red asymptote. Pi over 2 becomes pi over 6, and that's going to be over here. 3 pi over 2 is going to become pi over 2, so that becomes this one, and so on. So now instead of having asymptotes every pi, now I'm going to have asymptotes every pi over 3. So I have one here, I have one here, I have one here, I have one here, I have one here. Okay, and so I drew all my asymptotes every pi over 3, and now I can draw my blue tangent functions centered between the asymptotes that I drew. Okay, so it's just when I have tangent of 3x, the tangent is narrower. Okay. Okay, so there we go. That's my tangent of 3x function. Number 2, describe the transformations which move the first curve to the second curve. Okay, so here we go. This says tangent of x becomes tangent of x minus 1 plus 2. This is simply a horizontal translation and a vertical translation. Horizontal translation to the right because bizarro world. So translate 1 unit to the right and 2 units up. Okay. All right. What about this one? This one has a vertical stretch and a horizontal stretch. So let's do the horizontal stretch first. Dividing by 2 seems like it would make it smaller, but Bizaho world, so it's going to make it twice as wide. So we're going to have a horizontal stretch by 2, and then we're going to have a vertical stretch by 2. Okay. Number 3, state the period of y equals tangent of x. We know that the period is pi, right? If it was sine or cosine, it would be 2 pi, and if it's tangent, it's pi. What about for the function tangent n times x? So n, that is going to make the tangent function narrower or wider. In the case that n is bigger than 1, it would make it narrower, right? And in the case that n is less than 1, it would make it wider because of Bizaho world. It's opposite, right? What is the period in this case? Well, remember, n would be b, so the period would be equal to pi over b, and in this case, it's pi over n. Okay? So that's why when n gets bigger, the period gets smaller, and vice versa. Okay, 10f, general trig functions. Which function has a period that is half the period of the other functions between sine, cosine, and tangent? Of course, the tangent has a period of pi, and sine and cosine have a period of 2 pi. So the half size period would be tangent of x. Which have peak-to-peak heights of 2? Okay, so remember sine and cosine have a peak-to-peak height from -1 to 1, so that would be a height of 2. So that would be sine and cosine. Tangent, you can't really talk about its peak-to-peak height because the range is negative infinity to infinity. Which has a domain that is not all real numbers? So sine and cosine, remember, the domain is all real numbers. Tangent has vertical asymptotes, so there's some values of x which tangent doesn't exist. Which has a range that is all the real numbers? That would be sine and cosine. For the general functions for sine and cosine, give the relationship between b and the period. That would be b equals 2 pi over p, or p equals 2 pi over b. And do the same for tangent. So for tangent, remember that the period is pi instead of 2 pi, so the relationships look like this instead. Okay? All right. Page 6. State the amplitude, where appropriate, of y equals sine 4x. Okay, so remember the amplitude is the number that's multiplied in front of sine 4x, so the amplitude is 1. C, in this case, y equals negative cosine blah blah blah, the amplitude would be -1. Number 2, state the period of tangent of x. Remember the period of tangent of x is just pi. State the period of sine blah blah blah. So in this case, we're going to look at the b because that affects the period. The period of sine would be 2 pi over b, so it would be 2 pi over 2, which simplifies to pi. So normally the parent function of sine of x has a period of 2 pi, but when b is 2, then the period becomes pi, just like tangent of x. Okay, find b given that y equals sine bx has a period of 2 pi. So if the sine function has a period of 2 pi, then we can find the b value by doing 2 pi over the period. So it would be 2 pi over 2 pi, which is just equal to 1. That makes sense, right? When the b value is 1, the period for sine is going to be 2 pi. What about the b value when tangent bx has a period of pi over 2? So we'll just put pi over p, which is the same formula except for tangent. And then for period, we're going to put pi divided by 2. And pi divided by 2 is pi times 2 over pi, which is equal to 2. Okay, so the b value in this case is 2. Sketch the graphs of these functions between 0 and 2 pi. So in this case, I have a tangent function, which is horizontally translated, and this is to the left or to the right. So this looks like it would be to the right, but it's bizarro world, so it's to the left by pi over 2. Okay, so first I'm going to draw the parent function of tangent. Tangent, remember, has vertical asymptotes here and here, kind of like that. Okay, oops, kind of like that. Okay, and what we're doing is we're going to shift it to the left by pi over 2. So I'm going to draw it in blue here. Okay, so there is my function that is translated to the left by pi over 2. Okay, number 5. State the minimum and maximum values where appropriate of y equals negative sine 5x. So the amplitude is basically 1, right? Although it's negative 1, it doesn't really change the peak to peak height. The maximum value is going to be 1, and the minimum value is going to be negative 1. Okay, so those are the maximum and minimum values of this function. For 2 tangent of x, okay, tangent of x, remember, extends from negative infinity to infinity, so multiplying by 2 or not doesn't really change that. Okay, and for y equals 1 plus 2 sine x, remember that plus 1 is going to vertically translate the whole thing up by 1. So instead of going from negative 1 to 1, it's going to vary more. And hey, look at the a value, it's 2, right? So maybe we'll draw a picture. So the mean line is going to be at 1, okay? But the sine function is going to go up and down 2 units. So it's going to go as high as 1 plus 2, which would be 3, and it's going to go as low as 1 minus 2, which is negative 1. So basically here, the minimum value is going to be negative 1, and the maximum value is going to be 3. Number 6, state the transformations which map sine of x onto negative sine of x. And so basically this is a reflection in the x-axis, right? It's going to flip over the x-axis. So if it starts out looking like that, it's going to flip over the axis. It'll look like that. Okay, let's look at the next one. Y equals tangent of x. We're going to do a transformation which maps it to here. This is going to be a horizontal transformation. Okay, and it looks like it would be going to the right, but it's a bizarro world, so it's going to go to the left by pi over 4. Okay. And number 7, find m and n given the following graph is of the function y equals m sine x plus n. Okay, so in this case, we have an amplitude change and we have a vertical translation. So for this particular case, they're talking about this graph here, you can see that the mean line is at negative 3. Okay, so that means n has to be negative 3. And then as far as like its peak to peak values, it goes from negative 5 to negative 1. So the distance between negative 5 and negative 3 is 2. The distance between negative 3 and negative 1 is also 2. So m is going to be 2. And it's going to be positive 2 because you can see that the main shape of sine is maintained, right? Okay. Now let's look at number 8. Find p and q given the following graph. This graph here is of the function y equals tangent of pt plus q. Okay, so you can see that compared to the parent function, which is centered here at the origin, it's moved up by 1 unit, right? So vertically translated 1 unit, so that means q is going to be 1. And we can see that normally the tangent function has asymptotes at negative pi over 2 and pi over 2. And in this particular case, the transform function has a much wider interval between asymptotes, negative pi to pi, instead of negative pi over 2 to pi over 2. So we can see that it is horizontally stretched by a factor of 2. We can also look at this and say, okay, the period of this function is from negative pi to pi, so the period is 2 pi. It's the same period as sine and cosine, right? So for tangent, I can figure out the b value, which is the same as the p value, by doing pi divided by the period. And in this case, the period is 2 pi. So b is going to be 1/2, or p is going to be 1/2. Okay, so, and then q is going to be 1. All right, that's it for the last page.